This is the second paper that I'm doing for IB. This is a 40-mark IB exam paper. I'm going to split it into 4 videos, each with 10 questions. You can check out the other videos in the playlist in the link in the description, and you can also download the original questions with no answers, so you should have a go at the questions before you look at this video. Okay, so question 1. Which of the following correctly describes the changes in kinetic energy of the molecules and potential energy of the molecules as a liquid changes phase to a gas? Well, as the phase change happens, the change in temperature is 0. And if the change in temperature is 0, then the change in the kinetic energy of the molecules is 0, because remember, temperature is average kinetic energy. So it must be either A or B. The potential energy of the molecules, if something's from a liquid changing into a gas, then the particles are going from being relatively close together to being extremely far apart. So the potential energy of the molecules must increase, and so it is A. Question 2. Light passes through a single narrow slit and illuminates a screen. What is observed on the screen? Well, this is white light that we're talking about, and so if you shone white light through a single slit, you would get a single central white maximum, but all of the colors of light all of the different wavelengths of light would diffract a different amount, and so apart from that central white maximum, you wouldn't get any other white light. Everything else would be colored. So we're looking for a white central maximum surrounded by colored fringes. Question number 3, the period of vertical oscillation of a mass spring system is T when the spring carries a mass of 1 kilogram. What mass should be added if the period is to be increased to 1.5 T? Okay, well, we know that T is equal to 2 pi root m over K. So it's saying we want to make T 1.5 times bigger. What do we need to do to m? So if we call that T1 and m1, and then we have T2 is 2 pi root m2 over K, and we know that T2 is equal to 1.5 times T1. So then we've got 1.5 T1 equals 2 pi root m2 over K. And so now we've got two simultaneous equations here, which both have T1 in them. So we can say that 1.5 times 2 pi root m1 over K is equal to 2 pi root m2 over K. Now lots of things can cancel now, so we can cancel, let's change colour so we can see what we're cancelling. We can cancel the 2 pi, we can cancel the divide by root K, and then we're left with 1.5 root m1 equals root m2. If we multiply out, then we get, if we square everything in the equation, then we get 1.5 squared equals, 1.5 squared m1 equals m2. So we need to square 1.5, which gives us 2.25. m1 equals m2. M1 was 1 kilogram, so that's 2.25 kilograms equals m2. Now, the question says what mass should be added to the 1 kilogram. And so if the total mass we want is 2.25 kilograms, we need to add 1.25 kilograms, which is C. Okay, a mass at point X gives rise to a gravitational field strength G at point P, shown below. An identical mass is placed at point Y. The resultant gravitational field strength at P is now. Well, the gravitational field strength was only pulling this way, but now, yes, Y is further away, but there's still going to have some gravitational field strength pulling the opposite direction. Gravitational field strength can be a vector, so it is going to be less than G if that's G, but not 0 because Y is not exactly the same distance away, so it's going to be between G and 0, which is C. Question number 5, the table contains statements about stationary and progressive waves. Which row is correct? Okay, let's look at the stationary wave column first. So all particles vibrate with the same amplitude. Well, in a standing wave, if you have a standing wave like that, then this particle here, the amplitude is that much, but this particle here, the amplitude is that much. So That is not true, so it's not A. Energy is transferred along the wave. Well, the net transfer of energy in a standing wave is 0, so that's not true. On part C, particles in adjacent loops vibrate in antiphase. Well, if we have, what it means by that is here, this particle is going down when this particle is going up. These are the adjacent loops, these two. So that's correct, that one's right. And particles one wavelength apart vibrate in phase. Well, if we've got a standing wave like that, then one wavelength apart, this one's going up, this one's going down, this one's going up. These two are one wavelength apart, so they are in phase, so that one's true as well. So it's either C or D, so we need to figure out which one of these progressive waves ones is false. Well, in a progressive wave, particles vibrate in phase with their immediate neighbours. Well, if a wave is travelling this way, then this one is at its peak maximum displacement here, and this one is almost at its maximum displacement, but it's still going to move up a tiny bit more, and then this one needs to move up even more to get to maximum displacement. So none of those are in phase with each other. None of those are reaching their maximum displacement at the same time, so that one is not correct. So it must be D. Question number 6. A rectangular coil is placed in a uniform magnetic field between the poles of the magnet as shown in the diagram. When a current is passed around the coil in a clockwise direction, what happens? Well, if you remember that a coil behaves like a bar magnet. So what we're doing here is we're looking at the end of the coil. And so this is the end, here is the end of the bar magnet. So you can figure out which end you're looking at if you draw the N and the S and then you draw arrows at the end of each one. So the north pole, the current is flowing anti-clockwise like this, and the south pole, the current is flowing clockwise like this. So here our current is flowing clockwise, so this is the south pole of a magnet. So the south pole of the magnet is going to be repelled from here and it's going to be attracted to here. So this is going to move, this is going to rotate around this axis. So the answer to that, therefore, is D, 6D. Question 7, the rate of global warming. Well, this is more of a memory question. There's not really many calculations to do for this one, but the rate of global warming might be reduced by reduction in the Earth's albedo. Albedo is how much it's reflecting the incident radiation. So if it's reflecting less, then that's going to increase the rate of global warming. Reduction in carbon fixation. Carbon fixation is like carbon capture. It's reduction of the amount of carbon in the atmosphere, so it's not that one. And an increase in deforestation. Well, if we cut more trees down, they're going to remove less carbon dioxide from the atmosphere, so it's not that one. So it must be replacing the use of coal and oil with natural gas. And natural gas is considered to be a cleaner and more environmentally friendly fuel than coal and oil. Question number 8. At an atomic scale, which one of the following correctly lists the 4 fundamental interactions in order of increasing strength? Well, gravity is by far the weakest. Gravity is extremely weak, something like 10 to the 34 times weaker than the strong force. And the strong force, it's in the name, is the strongest force of the 4. So the only option with that is D. The weak force is called the weak force, but it's not the weakest because gravity is extremely weak. So gravity, weak, electromagnetic, strong is the correct order. Question number 9. The velocity time graph for an accelerating object travelling in a straight line is shown below. Which of the following is the change of displacement of the objects in the first 5 seconds? Well, remember that the change in displacement of an object is just the area under a velocity time graph. So you've got 5 times 5 divided by 2, so 12.5 meters. Question number 10. A particle is projected horizontally with speed v from height h. It lands a horizontal distance r from the point of launch. Then a second particle is launched from the same height with a speed 2v. Neglecting air resistance, how far does it travel? Well, remember that the amount of time that it's in the air is dictated only by the vertical height, h. So the time is going to stay the same. So if the time is staying the same, remember there's no air resistance in this example. So all that is happening is we want to find the distance, and we have the time is the same, and we have the velocity has doubled. So if this velocity doubles, then this distance must double as well. So we're looking at 2rc. Remember, this was just the first 10 questions. There are 30 more. Check out the link to the playlist in the description below. And remember, you can also get the unanswered questions from the link in the description below as well. Thanks for watching.